So we started with database, right? We talked about database, what is database, what is data. We started with data actually. Then we seen what is information, what is database, what is RDBMS, DBMS, and what is data warehouse, and how these terms are actually related. How one thing is actually dependent on another thing. And later on, we are talked about types of data: structured, semi-structured, quasi-structured, and unstructured data. And then we talked about big data also. So there are a lot of forms in which you are going to get your data, and you need to apply statistics as well as data mining. Many times you will need to apply on that, and you need to get the desired output. Right? That's what we have seen till now with the basic which we require for understanding this particular subject. So I started with this particular part. I started with data mining, right? And we are going to need this particular part also, as I told you that data statistics plus data mining, these two things we are going to require to understand this particular subject, right? Because as you check, suppose if you go and if you try to check the course objectives of this subject, they are saying that it is going to enable students to learn about how to develop models to predict categorical and continuous outcomes. So that what is categorical data, what is continuous data, we should be clear about that, right? So again, we will try to see that. And talking about all these objectives, I will be showing you these things. Neural networks. So developing models with the help of neural networks, decision trees, logistic regulation, support vector machines, Bayesian networks. These are some of the algorithms which you might come across in machine learning or data science. But on my part, I will be trying to discuss all these things practically also, if possible, if we get more time. Okay, so I will discuss all those things with algorithms also, right? And with implementation of each and every algorithm, plus we will create the models. So, to know the use of binary classifier and numeric predictor nodes to automate model selection, that is one objective, and to advise on when and how to use each model, right? And also to learn how to combine two or more models. So, combining two or more models is going to be our end-to-end project. That's what we actually generally do in real time also, right? And course outcomes are like this: understand the process of formulating business objectives, data selection, collection, preparation process to successfully design, build, and evaluate and implement predictive models for various business applications. So once we are done with the discussion of some of the points from this first unit, I will be talking about the complete flow of developing a predictive model in machine learning, data science, or maybe with the help of data mining, and how we actually make use of statistics in that case. So I will be talking about the complete flow, which we also follow in industries, right? And the course, another course outcome is compare and contrast the underlying predictive modeling techniques. So you have a lot of different techniques and algorithms which are available for creating the models. So you can go and you can compare them on the basis of their accuracy, on the basis of their test score, what type of accuracy is there in case of training data, testing data, and how much time they have actually taken to develop that particular model. So all those points are going to come into picture whenever we want to compare different models. Then the another outcome is select appropriate predictive modeling approach to identify cases to progress with. So once you create the model, once you understand the data, once you understand the model itself, you will be in a position to identify different use cases, right? Which can help you to make sure that okay, you can go and you can expand that particular model to the next level and apply predictive modeling approaches using suitable packages in R programming. So I told you it can be R programming or it can be Python. It doesn't matter. Concept is what is important. But yes, we will try to talk about some examples in R and some examples in Python, as I told you. Okay, so let's try to discuss about these things. Data mining, I already told you. I have given you the introduction. Data mining, I already talked, right? So today we will try to define data mining and we will try to see some concepts which are related to data mining. We will talk about technologies used. We will talk about the complete data mining process and mainly KDD process model in data mining. Plus, we will talk about this CRISP model of data mining. What is that? What is the flow of that? Which are the points you are going to come across whenever we talk about KDD or whenever we talk about CRISP data mining. So we will try to talk about all these points. Again, these are theoretical points. They are not difficult. They are not difficult to understand. So but yes, I will if you ask me, practical approach is what is very important to understand all these things. Okay, so anyway, let's start with this particular thing. What is data mining? So as you have already as you are already familiar with the basic concepts like data, database, data warehouse, information, and all those things. There we have already talked about data mining, that data mining is going to help you to identify the patterns, right? But again, in other words, if I want to define it, or maybe for your exam point of view, if you want to write down some definitions for data mining, you can define it for that purpose also, right? So I can define it like this: it's a process. Data mining is a process of maybe discovering patterns in large data sets, right? So whenever I say patterns, so data mining helps you to discover patterns in large data sets. That is single sentence definition of data mining, I can say. So it's a process of discovering patterns in large data sets which involve methods at the intersection of maybe machine learning or statistics or maybe database systems, right? So I can say data mining is it can be used in machine learning, it can make use of stats, it can make use of database, right? So I will define it like this: it's a process of discovering patterns in large data sets which involve methods at the intersection of these three things: machine learning, statistics, and database systems, right? Again, it's not like that. This is, yes, any question given?
Yes, sir. Sir,
Yeah.
can we say that the stock market is a data set and data mining can be done on the stock market?
Stock market is a domain, right? And stock
Yeah.
market domain makes use of data mining. Yes, it makes use of
Sir,
data mining.
time series is
Yes,
used, no?
yes,
Time series.
so yes, in that case, time series data is used. So time series data you might be knowing, right? Whenever we
It's
talk about
we
time series
split
data,
the data according to the time.
yes, 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 yes. So you might be knowing about then this one. Whenever we talk about time series data, you will come across these things: downtrend and uptrend,
Uptrend,
right?
yeah.
And there is one more type of a trend in case of a time series data, which is called as no trend or horizontal trend. So diagrammatically, I can represent it like this. So downtrend is uptrend is like this, something like this, right? You might have seen this kind of diagram. Downtrend is like this. It was higher and then it is decreasing, and no trend is like this.
Sideways.
That means it is not increasing, not decreasing, right? So yes, in time series also we can apply data mining. That's why, see, that's why I told you, whether it's machine learning, data science, neural network, or deep learning, data mining is going to be there. Or see, I will go further and I will tell you that I will say that this particular term machine learning is, to some extent, see, to some extent it is similar to data mining. Are you people getting my point? I will say that to some extent machine learning is similar to data mining. Obviously, defining a machine learning is, again, that will be something different. Uh, that's not the thing which we are going to use here, but yes, machine learning makes use of data mining. So whether it's a time series data, whether it's a stock market analysis data, maybe any type of a real time data you talk about, maybe healthcare data, maybe data which is related to sports, right? Banking domain, financial domain, whatever it may be, data mining is always going to be there, right? So just try to understand. You talk about any example, data mining is there, because without data nothing is possible, right? So that's how we can define data mining. Now, if you ask me, for example, maybe you can go and you can apply different steps to, what you can say, to fetch the required patterns from the data, right? So I can just write it down like this. I can show you. If you ask me what can be the general flow of data mining, right? So talking about, as here we are talking about what is data mining and concepts of data mining, okay, or data mining process, specifically data mining process. So I can just go and try to talk about some of the points which actually is what you can say, which can be part of a data mining process, I can say. So obviously the first and foremost point is going to be what you need to identify: the data which is going to help you to achieve your target. Maybe time series data it is, maybe stock market analysis, whatever it may be. It depends on that domain. Okay, domain to domain it is going to change. So first of all, identification of the data is going to be very easy, because without that you cannot proceed, right? And then there can be, once you identify the data, now you go and you prepare the data. Now we will try to talk about what we mean by preparing data. So if you remember, yesterday I talked about some missing values, null values, or any values, right? So it depends on some languages. In some languages we denote it as NA. In some languages, in databases particularly, we denote it as null value, NULL. So specifically in databases like MySQL or Oracle, missing values are denoted as or stored as NULL. Suppose in case of Python or R, we denote it as NA, right? It is just, but again, that is just a representation, but the meaning is same. So once you identify data, you need to prepare the data, because yesterday I told you that if you talk about creating models, for almost all the algorithms which help you to create the models, for almost all of them, your data should be clean data, right? So we need to prepare the data. Preparing data means removing the missing values, adjusting the outliers if there are outliers, removing them, and so on. You will see that in practical also. I will show it to you step by step what kind of a data is going to be clean data and what we do in this particular step, preparing data, right? So one of the examples is removing your missing values or handling missing values, okay? Or another term we can make use of is imputation. So identifying the data, preparing the data, and then from that data you can go and you can create the model, right? Model, application or project. It can be a web application, it can be any application, it can be a complete desktop project, it can be anything, right? Most of the times you will see that it will be a model or it will be part of a bigger project, it can be, right? So first identify the data, prepare the data, and then model and evaluate the data. With the help of model, evaluate the data. This can be the another step which can be applied in data mining process, I can say. Once it is done, then you can go and you can present the data or present the output in front of the customers or the targeted people, that you can go and you can present it. And once it is presented, you need to go and you need to check whether the goal which you set earlier, whether the goals are achieved or not, or that is nothing but business goal. So why are we doing all these things? Because we want to achieve the business goal, right? So this cycle can continue like this again and again, again and again. If the goal is not achieved, again repeat the step, again go and follow this particular step, right? So this can be in a nutshell, I can say this can be the process of data mining, right? And again, as I told you that data mining can be defined in number of ways. It's not like that identification of patterns is the only definition of data mining. No, there are other definitions also. For example, in simple words I can say this data mining is defined as a process to maybe extract the data, right? To extract usable data, I can say, to be more precise, to extract usable data from large set of any raw data, and it implies analyzing data patterns in large batches of data using one or more softwares, right? And many times you will see that data mining is also known as KDD. That is the term which is used in your syllabus. If you go and if you try to see the syllabus of the first unit, you will see this particular term, KDD. KDD. So actually KDD stands for, remember this, exam point of view also it is important. It is
Knowledge discovery.
discovery data, right? KDD. So many times you will see this term is interchangeably used for data mining, okay? Knowledge discovery data. So again, now you might have got uses of data mining where it can be used. So to be more precise, if I want to tell you, okay, it's a process used by many companies to turn your raw data, right? So into useful information. So this is what data mining also does, to turn the raw data into useful information. Many companies make use of this data mining concept for doing this particular thing, converting raw data into information by using some softwares to look for patterns in large batches of data. Businesses can learn more about their customers to develop more effective marketing strategies, and they can increase the sales, or they can decrease the costs, right? So that is how I can define data mining. Now again, you will come across different types of data mining, right? So as we have seen that this data mining term actually helps to extract information from huge sets of data. It is the procedure of mining knowledge from the data, right? That's why the name data mining. So important data mining techniques, I think I have discussed already, like classification, clustering, regression. Some association rules are there. Some outlier detection techniques are there, or sequential
Anomaly
patterns are there.
detection.
Right. So these are some of the techniques of data mining, I can say. I think we have discussed that particular thing also, right? So let's try to discuss about the next point now from your first unit. If you see in your first unit, they have mentioned the data mining process and they have mentioned this KDD process. So let's try to discuss about this KDD process model, and maybe if we have time, we will try to discuss about this CRISP model also. CRISP data mining. We will see that what it is and how it can be useful and how actually it makes use of this basic concept, that is data mining. So let's see what is this KDD actually. Let's talk about that one. So I think did we talk about KDD in last class? Knowledge discovery data? No. Did you talk about this one? Steps involved in KDD, knowledge discovery data process. Can anyone tell me? Did you talk about this particular point last time?
No, sir.
Okay. Let's try to discuss. So knowledge discovery data. Till now we have seen that KDD sometimes is used as a what you can say another term for data mining. Let's see what are the different aspects here. What is this process and which are different points here. So initially we will be having data, right? So obviously data is going to be stored in some databases. So we will be having databases here. For example, something like this I will be using for databases. So these are the databases. From the databases only you are going to fetch the you are going to fetch the data and you are going to apply other operations on the data. Now as we are talking about steps involved in KDD process, so obviously KDD is related to data mining. It is going to make use of data mining.
Data warehouse.
So we have data warehouses here, right? So something like this. Suppose this is what your data warehouse is, and when are you going to fetch the data from the databases into data warehouse? Obviously, you need to do data cleaning. So you need to clean the data. For example, removing the NA values, removing the missing values, right? So from the databases, now that your data is in data warehouse after cleaning. Once that is done, you can go further and you can apply some data selection and data, what you can say, data transformation techniques here. So data selection and data transformation. So you can apply data selection and data transformation techniques. So data selection means what? Suppose you have 300 features, 300 columns in your data, and for your purpose you only require the important columns are only 100 columns maybe. So you select whatever is required, right? And data transformation means maybe you have more features needed. You need more features to achieve your target. So in that case, you need to go and you need to add some more columns. So data selection and data transformation. So I think we talked about those statements like DDL, DML, DCL, ECL. So what DDL stands for? If you know about SQL language, do you have any idea about SQL? Structured query language, anyone? Have you learned this in any of the?
Yes, sir. We have learned that skill.
So DDL stands for what? Anyone? DDL stands for what? What is the full form?
So data definition language.
Data definition language. Which are the statements under DDL from SQL? Which statements are there in DDL? SQL
So
statements.
we don't know in detail, sir. We don't know in detail.
No, I am not asking you in detail. It's a very basic thing, right? If you tell me this concept, was it in your syllabus previously? Did you come across this particular concept? Okay, see,
DDL, DML.
Prashant, you are saying that we know only MySQL, so that's what I want. If you know MySQL is a database, and to talk with the database, you use this particular language. You might have hired the commands like, are you familiar with this one? Select, star,
Yes, sir.
from.
Yeah, sir. Yes.
So that means you are aware about SQL language. Okay.
Yes, sir.
Just name a few statements like select. Which statement you use?
Alter, sir.
Alter. Any other thing?
Delete.
Delete. Any other thing? Any other statement you might have
Or
used?
from.
Okay, from is a keyword.
Nahi,
From is a keyword
from nahi.
actually.
Okay.
Create a database, then create
So create,
database
see,
name.
always remember, after this point, always remember. I will just try to tell you. Again, you are going to require all these things in analytics, in data mining, in data science. Even if you know statistics, you are going to require. See, create, always remember. I am writing down DDL statements. Okay, create, alter, drop, truncate, and rename. Remember, these are called as data definition language. DML. DML stands for data manipulation language. So under data manipulation language, we have statements like insert, update. Anyone heard about these statements before? Insert,
Yes, sir.
update, delete, and merge. Many times people will tell you that okay, there are three statements only which will come under DML, but yes, merge is also there. Okay, insert, update, delete, merge. DCL. Can anyone tell me what is the full form of DCL?
The query.
No. That is DQL. So SQL is actually divided into these five categories. SQL statements are actually divided into these five categories.
The control language.
Right, data control language.
Data control language.
Data control language. So can you remember any statement? Do you remember any statement which is related to data control language category? Anyone?
Sir, create database and we have to
No.
give that.
So remember this: grant and revoke. Okay, grant means give the permission. Revoke means take the permission from the user. Right? And TCL stands for what? TCL. Anyone? TCL. Whenever we go to ATMs for withdrawing money,
Transaction control, sir.
transaction, that is called as transaction. So transaction control language. It is transaction control language. Which are the statements under this? Anyone? First one is called as commit. Now you remember another one? Commit and rollback. Right. Can anyone tell me the example of DQL? Just see which one is not there, which one I have not listed down. Which one is remaining? Create, alter, drop, truncate, rename, insert, update, delete, merge, grant, revoke, and commit and rollback. Everything is done. Which one is remaining?
Query.
Which statement is remaining?
Okay.
Yes, anyway.
Select.
Right. Select is remaining. Select is remaining. Right. So select is data query language. Okay. So remember this: DDL, DML, DCL, TCL, and DQL. Maybe not now, but yes, definitely these things are going to help you a lot later on. Right. And that's not difficult. SQL is like English language. Most of the times you will see, you will understand it. Okay, not difficult to understand. So we were talking about steps involved in this knowledge discovery data process. So the first one is data. From the databases, clean the data and just go and load it into data warehouse. Whatever the data you have in data warehouse, now apply data selection and data transaction techniques with the help of SQL kind of a tool which you can make use of on any database. Right. Now, once your data is in data warehouse, you can fetch the data which is only required. So, for example, you require specific data only. That means I can say the task which you want to perform. So, for that task, what you need is task relevant data. Whatever is required, only fetch that one. Do not try to fetch the data which is not required. Okay, unwanted data you should not fetch. So, task relevant data. Again, why? Why to increase the size? If you increase the size of the data, obviously memory is going to increase, and if it is going to increase, obviously speed is going to decrease, right? So it's like just take an example of your mobile phone. If you have a lot of data on your mobile phone, obviously it's going to slow down because it's going to make use of the RAM, right? Random access memory, which is a primary memory. That's what is going to happen in case of servers also. So why to waste the space or the memory for unwanted data? So that's what just take the data which is required for your task. That is task relevant data. Once that is done, now you can go and you can try. You can go and you can apply data mining here. Okay? You can apply data mining. Now, what do you mean by data mining? So just now we have seen the definition of data mining as it's a process
Patterns.
of finding out the patterns in the data. So you might go and you try to find out the patterns. For example, you have plotted something like this. So you found out some patterns, right? Something like this. So it's a graph, actually, one type of a plot, right? So here you got pattern, some pattern for your data. Here you got some pattern for your data. So and you, with the help of again some techniques, you are going to do what? You are going to evaluate that pattern, and that is called as pattern evaluation. Once you know that okay, the pattern is good because everything is okay and I'm able to understand each and everything, and from that now you are going to get the knowledge or whatever what you are going to get the domain knowledge or whatever was required, you are just trying to get that, right? That was our ultimate objective. Once you got the knowledge, now from this knowledge you can go and you can make decision, or decision making is possible. And once you have, so we are not going to make the decisions randomly in business, right? You should have something concrete on the basis of which you can go and you can apply, you can make decisions so that they will help to increase the profit and avoid the risk or minimize the risk, right? So once this is done, so this is KDD process, but we are not done yet, right? So even though we are actually trying to get the knowledge ultimately, so that there can be reverse way also. From this you try to get some patterns also, right? Then uh, there might be a need to go to data warehouse once again and try to find out if there is anything new, right? That is also possible. Or again go to the database directly and repeat the step once again. So this complete process is called as knowledge discovery process. Okay? Knowledge discovery process, which is going to make use of data mining. That's why I told you data mining sometimes or KDD is sometimes used as an interchangeable. They are many times used as interchangeable terms. So here we started with what? Here we started with data cleaning, right? So data cleaning is defined as removal of noisy or irrelevant data from the collection or from the database. So cleaning in case of missing values, cleaning noisy data where noise is random or variance vector, right? Cleaning data with what you can say data discrepancy or data transformation tools. You can make use of different tools to clean the data. One of them is SQL, right? SQL is one of the tools which you can make use of to clean your data to perform this particular operation with the data from the database. Then another steps like data cleaning, this KDD process may involve something like data integration. So data integration is defined as heterogeneous data from multiple sources combined in a common source. So as I am talking about databases here, so it's not like that it's always going to be only MySQL database. No, it's not like that. It can be, the data source can be a CSV file, right? You might be knowing CSV file, comma separated values. The data source can be MySQL database, it can be Oracle database, it can be MongoDB database, it can be Hadoop, it can be anything. It can be social media data. So what we need to do here is we need to apply some data integration also. So data integration is what? It is defined as heterogeneous data from multiple sources combined in common source. And what is that common source? It will be combined into data warehouse. So data integration using some migration tools, we are going to make use of some synchronization tools. And whenever we talk about this particular thing, whenever we talk about storing your data from multiple sources into data warehouse, there comes a term that is called as ETL. ETL actually stands for extract, transform, and load. Right. So you will see in organizations there are many people who are just working with the help of ETL tools only. So there are a lot of ETL tools you will come across in future maybe. So for example, the tool which I have worked in is SAS, Statistical Analysis System. I worked with Informatica, right? There is something called as pervasive. These are the examples I am trying to give for ETL tools. And now you will be able to see some tools like Tableau, Power BI, which is a product of Microsoft, right? So there are different tools which you can make use of as ETL tools: extract, transform, and load. What is extract? Extract means trace the data from the source. In terms of source, source can be one or maybe multiple sources, as I told you. Transform means according to the need, whatever you require, just try to get that. do not try to fetch the unwanted data, right? Because it is going to cause a problem in later stages, right? And then load means what? Once you have your data, now load that data into data warehouse. The data which is required, only that data you load and you move forward, right? So as I talked about data selection can be defined as a process where data relevant to the analysis is decided and retrieved from the collection, that is databases. So again, data selection.
Transformation means, sir, feature selection, na, in short, sir, which features are going to contribute.
Yes,
So that
feature
only we
means
have
column.
to
Yes, yes. Data transformation means, see, it can be feature selection plus it can be adding extra features if needed. That means
okay.
either remove some columns or add some columns. Sometimes it depends on in which domain you are working or what is the problem statement. So yes, it can be selecting the required columns or maybe adding some columns if required. Feature, whenever I say feature, in terms of table, it means column. Clear?
Yes, sir.
Okay. Yes, and let's see if anyone any doubt in between, you can stop me, you can ask me, or otherwise you can ask your question in the chat box also. No problem.
Sir, where do we handle the missing data, sir?
Data cleaning. Data cleaning.
Okay.
SQL.
So again, not only SQL, it can be SQL, it can be Python, it can be R.
R.
Are you
Yes,
getting
sir.
my point? It depends. It depends on what type of a team you have.
Sir,
But
if we have CSV file, then we have to clean in Python and R, right?
no, even with the help of SQL also, you can. What you can do? You can go and you can store that particular data into some database also. But using Python like thing or R like thing for CSV is good,
Yes, sir.
right? That is not the only option, but these are the best options. That's why we generally make it option. Again, why base? Maybe when I will talk about some practical implementations, I will talk about those ones.
Sir, if we have a huge data set, then I think so Python is not good, I think, because I have heard that R and Python cannot
Then what are you
clean
going to
properly.
use then? If you do not use Python and R, then what
That SQL is used, I have heard,
SQL is structured query language, right?
for
So
cleaning large data sets.
it's not like that. See, in real time, that's what is going to happen. You are going to get huge data only. Do not expect only 1,000 rows or 10,000 rows. You are going to get millions of rows. And we use Python, no problem. What we can do is we can apply some techniques before fetching the data. Are you getting my
Yes,
point?
sir.
So some techniques means what? Instead of trying to fetch the whole data, what you can do is you can form the clusters of data. Do you understand cluster?
Yes,
Yes.
sir.
What do you mean by cluster?
Sir, small group we form some,
Sir,
and then
homogeneous grouping,
Right.
same
So
characteristics.
right. So for example, I have in my case, so see, this is one row, second row, third row, fourth row, and so on. These are the data points in my data set. A lot of data, big data is there, huge data is there. So rightly said, it may be any technology. No technology can handle huge data. So that's why what we do is we try to apply clustering on that data. So we apply clustering here. Can anyone tell me any clustering algorithm? Anyone knows about it? Clustering. Clustering means what? A cluster means group. That's it. Clustering means grouping. So what it is going to do? If you do not know clustering techniques, K-means is the best clustering technique for algorithm. There is another technique which is called as scan. Is also one of the clustering algorithms. So
sir, K nearest mean KNN.
no, KNN is a classification algorithm. K nearest neighbor.
Oh, okay.
It's a
Sorry.
classification algorithm. So this actually comes under supervised learning, and this comes under unsupervised learning.
Unsupervised
Do you
learning.
people also study machine learning subject?
No, sir, we don't have machine learning.
Okay. But you are going to require this knowledge for that. Okay, ML, data science. Yeah. Anyone? Any other question? I think someone was asking some question. Any doubt?
No.
Okay. So I was telling you that what happens is someone has asked me this question that okay, what if there is a huge data? So see, we will apply some clustering techniques, and now your data will be divided into different clusters. And now we will try to apply cleaning on this one, and so on. Are you getting my point? So we are going to divide that into small sets. This is what is going to happen if you have a very huge data. Okay, so that's how actually you can deal with huge data. So it's not like that you cannot make the R or Python in that case. You can. Obviously, you are going to require some what you can say. The hardware also should be very. The configuration should also be very hard, right? Obviously, that's what is going to happen, right? So that's how you can make use of these tools. Again, it's not like, okay, so if you have the if you know, if you are saying that, okay, I cannot use Python or R for that, no, it's not like that. We people are using, so no problem in that case. Okay. So that was about data selection. Data transformation, as I told you, again, if I want to define it, it can be defined as the process of transforming data into appropriate form required by mining procedure, right? So data transformation is actually a two-step process. If I want to talk about this particular thing, it's a two-step process. The first process involves data mapping, right? So data mapping, this is the first step in data transformation. Another step in data transformation will be code. We are going to make use of code generation or code generation. So what data mapping is going to do is it is going to assign elements from source base to destination to capture the transformations, right? And code generation is like creation of the actual transformation program, writing down the code maybe in SQL, maybe in Python, maybe in R, depending on the need. Okay, so that's how we are going to apply data transformation. In simple words, you can remember it. If there is need to add some extra columns, we are going to make use of some statements which are going to help you to add the features of the columns to your data. In simple words. Okay. After this, can say,
So just a second,
yeah.
could you clarify that mapping and code generation again?
Yes, mapping. See, in mapping, what is going to happen? Uh, it is going to assign elements from source. Okay, from source data. It is going to assign some elements from source base, that is our database in our case, to destination to capture the transformation. It means what? See, for example, in source, I have 1, 2, and 3 columns, very small data, just for example, right? So first column is for name, maybe name, okay, first name, middle name, last name, and address. Okay, so this is your source. Now, what we want to do, we want to store it into data warehouse, right? So before storing it into data warehouse, obviously you should have a similar structure in data warehouse ready. You should have a ready structure in the data warehouse also. Are you getting my point?
So
Yes, sir.
That means you should have at least have a blank tables, at least have blank tables to store, because we are going to move this data to here. So if you do not have a structure here, it's not possible to move this data to this one. Is it clear? Someone is asking.
yes, sir.
I think Disha, right?
Yes, sir.
Yes, sir.
Oh, yeah. So that's what that mapping is. That means mapping. So how many columns I have here? 3 columns. I should be having 3 columns here also. That means mapping. Mapping this structure to data warehouse, so that I will be able to store that. Right? Okay. So that is the thing. But mapping. Now after the data transformation, there comes data mining. So we have already discussed that, but again, uh, there are a lot of definitions of data mining. If you go and if you refer some books, you will get different definitions. But concept is going to remain same. It is finally going to look out for the patterns in the data or data warehouse, because we have seen that data warehouse is also database. So data mining is again can be defined as a clever technique that can be applied to extract patterns, which can be very which can be potentially used for your business, right? So data mining might involve transforming task relevant data into patterns. So whatever the data you got as a task relevant data, so what data mining is going to do is data mining is going to convert it into different patterns which are related, which are useful. And data mining can be used to decide, or data mining actually decides purpose of model using classification, or maybe some another technique like characterization. So here it is going to make use of some techniques, as we have talked about different data mining techniques like classification, regression, and all, or recommendation. So it's going to make use of all those techniques here, and it is going to get some patterns or evaluate the patterns here, right? So once you have this data mining applied onto task relevant data, you are going to evaluate the pattern, right? Okay, and let me tell you one point, all of you. If I am moving too fast, please let me know. Okay, if you are not getting anything, please let me know. I will slow down the speed. Or otherwise, if you think that I am going too slow, then also you tell me. So my ultimate purpose is that everyone should understand whatever I am discussing. So let me know whether I am fast or slow. Let me know. Okay. So pattern evaluation. Now, what happens in pattern evaluation? Again, it can be defined as as identifying strictly increasing patterns representing knowledge based on given measures. So, for example, something is varying very much, and something is not varying that much. So, right. So again, it's a pattern identifying strictly increasing patterns which represent knowledge based on given measures. So maybe you can go and you can find out some interestingness of each of the pattern, or maybe this kind of a thing can be used for summarization and visualization to make data understandable by the user, right? Whether the person is a technical person or a non-technical person, he or she should also be able to understand whatever this pattern is actually trying to tell, right? Just to make the things easy to understand, I can say. Okay, and at the end, once the patterns are created, patterns are evaluated, there comes this one, knowledge representation. So knowledge representation again can be defined as a technique which utilizes visualization tools to represent data mining results. So again, when I said visualization tools, again, Python, R, Tableau like tool, and there are a number of tools you can make use of. Microsoft BI. So you can make use of visualization tools in knowledge representation. It all depends on your team. Okay, so it can be defined as a technique which utilizes visualization tools to represent data mining results. So how to represent data mining results then? So maybe generate reports, right? Report is one of the ways to represent the data mining results. Maybe generate some tables, reports, tables, maybe some rules, generate some rules. In case of recommendation engines, we call it as association rules, right? Maybe association rules, discriminant rules, classification rules, or maybe some characterization rules. It all depends on what domain you are working. Right? So try to understand these are the steps which are involved in KDD, starting from.
So, what are the rules that you talked about?
So I was talking about the rules which you can generate from knowledge which you got here in the last step. So rules means what? Those rules like maybe they can help you to generate. Okay, talking about rules. Rules is actually one of the outputs of, I can say, knowledge representation. So it can be a report in PDF format. It can be a table. It can be a classification rule. So if classification rule, it means what? It is going to help you to identify to which class a particular data belongs. Or it can be an association rule. What do you mean by that? Rule, I mean to say that it is going to find out the pattern, right? So see, suppose here in your database, you have a data of Amazon. Now we know Amazon is a e-commerce site where people go and try to purchase things. Now, depending on their patterns, once you do all these things with the Amazon data or Flipkart data, what's going to happen is we are ultimately going to get the knowledge representation of that data. That means what are we going to get? Either we are going to get some reports, tables, or rules. Rules means let's take some rules. For example, maybe if someone is purchasing uh, mobile phone online from Amazon, there is 90% chance that he or she is going to purchase the cover for that mobile. Are you getting my point? So this kind of rules you can derive from knowledge. That's why if you people understand, that is the reason why you get. You might have seen if, all of you might have done online purchasing, right? Online shopping. So many times you might have noticed that it is suppose if you purchase something, it will show you that okay, people who bought this also bought that,
Excuse me, sir.
right?
Yes.
Hello.
Yes, yes.
Yeah, so we can also get results in form of graphs, right? So, for example,
This is what I was telling you. Reports. That means graphs.
yeah, okay,
So reports can be graphs. See, this is a graph only.
yes,
Ultimately, we got a graph only. So from that also you can derive another graph. I was talking about rules. Rules means recommendation rules. Many of you
mm.
might have seen, right? On Flipkart and on Amazon, you might have seen that. Okay, you get a message.
The
The people who
recommendation.
bought that, yes, the people who bought this thing also bought that one. Or
Yes.
if you go and if you try to buy some courses or buy some books, they will tell you that okay, the people who bought these books, they have actually bought a bundle of these things. So from where are they getting all these things? They are actually getting it from the patterns which people actually follow.
Customer behaviors.
Behavior, right? So that,
Yeah.
but just to understand that behavior, you need to do all these things. Without that, we cannot go. We cannot go and randomly decide any recommendation rule or association rule. We cannot go. I will talk about a very interesting case study about recommendation.
Hmm.
Right? I will show you that particular thing in R, and I will show you.
Sir, there is a case study that I read, sir, regarding chocolates in the supermarket.
Right.
Uh, the chocolates were kept near the billing counter
Hmm.
rather than having a separate section, because it was noticed that people would prefer buying them while waiting for the bill
Right.
rather than buying it on, particularly.
Right. Right. Yeah, that's kind of thing because they have noticed that, right?
Yeah.
So how, so from where they have got it is actually they have got it from association rule. That is called as association rule. So if you
So you
people
mentioned two other rules as well. There was
uh,
classification, there's association.
there are other rules like characterization rule, maybe something like discriminant rule, which is discriminating the things, right? Differentiating the things. Characterization means what? Maybe depending on some text, they can decide about the products. They can decide about the rules. Right?
Mm.
Like this, there are other rules also. It depends. It all depends on domain. Is it clear?
Yes, sir.
And see, if you people want to discuss about all these things, if you want to learn about how one actually decides about the rule, or maybe what you can say, if you want to understand some techniques or algorithms kind of thing, to know that how one can get rules from the data, right? So there are different algorithms you might have heard about. There are algorithms like which are called as association algorithms, which are going to give you the output as some rule. So if you buy a thing A, you will definitely there will be a chance that you are going to buy thing B or product B. Okay? So we have those algorithms or techniques. Actually, I think that is not mentioned in your syllabus, but yes, whenever you talk about recommendations, definitely those algorithms or techniques can be used. If I want to show you, if you people are interested to implement and to understand this, see, if you want to understand theory part, if you want to even understand the implementation, that will be about this. But anyway, we will implement in R. This is called as the a priori algorithm. Anyone heard about this a priori?
No, sir.
No. If you want to understand it, you can go and you can check on my YouTube channel. So this is a really easy algorithm which will help you to understand how to create rules. I will show you the aim. I will show you directly the output what I got here. Let me just keep all these things. Yeah, I will tell you here. Again, I will be implementing this in one of your case studies. So if you want to understand the theory part, definitely you can.
Sir, does AWS use Prior?
Everyone,
Okay.
everyone makes use of prior algorithm. See, here if you check this particular example I have given, but as this is not in your syllabus, that's why I did not discuss. So see, finally what it is, what am I doing here is I have a data. If you are able to see that particular table, are you able to see the table here? Are you
Yes,
able to
sir.
see this data?
Yes, sir.
Right? See,
Yes,
what
sir.
is this? It is transaction ID and item set. So a person with transaction ID 1000, 1001, 2, 3, 4, Only 5 records I have taken. So just take, he purchased item M, he purchased item O, N, K, E, Y. These are all the items. Someone has purchased item D, O, N, K, E, Y. Someone has purchased M, A, K, E, and so on. Now from all these data, we need to find out what is going to be the association rule. And those association rules, all these companies, industries, they are going to make use of for what you can see for recommendation. See here, I will show you association rule directly. The output is, see, this is the output. Try to understand, if someone purchases item O and K, 100% he is going to purchase item G. Because see, all these are our items, okay? These are the products. So see, 100%, 100%. I got these rules, two rules. So that is called as market basket analysis. Someone purchased O item. Suppose someone purchased mobile phone, and someone purchased, suppose someone purchased mobile phone and someone purchases some cover.
Yeah.
Definitely he is going to purchase some another thing, like maybe
Charger.
USB charger, whatever it is, right? So this is nothing but it is called as, these are called as association rules. Whatever I was talking about there, these are the rules I was talking about. So a priori algorithm is one of the algorithms or techniques one can make use of to achieve that from the data. Right? Are you people able to make some sense here? Are you
Yes,
getting?
Yes, sir.
I will implement it. I will implement
Yeah,
it.
sir.
Let me just complete at least first few minutes. Let me complete it. I will implement it. I will show you a very good diagram in R, and you will understand the power of R actually. How it can be really very, very useful to make some sense out of the data. See, ultimately, what's the purpose of understanding statistics and data mining and database and all these things? Ultimately, one should be able to make the story, to create the story about the data, so that that thing is going to help business people, that thing is going to help, you talk about any domain, whether it may be a military and surveillance, whether it may be a healthcare domain, financial domain, anything, you need something to make decisions, right? And these things are going to help you there. So whether it's statistics, whether it's data mining, whatever it is, or whatever the techniques and tools we are learning actually, all those things, the ultimate purpose is that. Right? So yes, this is what your KDD process is. Right? This particular point I was trying to talk about, KDD process. So I hope everyone is able to understand KDD process, right? Now,
yes.
yeah. Now next thing we want to discuss is KDD process model we are discussing. Now we want to discuss this model, crisp data mining. So
So just a second.
yeah.
Here you talked about, like, back then I asked you what's mapping as well as what's the code generation step.
So code generation is just see, as I shown you this particular thing, right?
Mm-hmm.
These are the steps of that algorithm, suppose, which is one of the techniques to develop the rule, to write down the rules. But how are you going to write down the rules in real time?
Okay, okay.
This is what theory, right? This particular part, whatever you are able to see on my whiteboard here, whatever you are able to see, this is theory. But are you not
Okay,
going
so,
to?
so code generation is basically just literally just code generation
Yes, implement.
in the literal sense.
Yes,
Okay.
implementation. So for implementation, you are going to require some programming language like R,
Yes.
Python, Java, C, C++, whatever it may be. So that was the point actually.
So the NLP also is used, right? If we talk about e-commerce and all. So if someone searches watch, then he gets that ad in next day that he has searched that watch. So he's getting such
NLP,
ads
no,
because
NLP,
he has frequently searched that product.
so that's what a recommendation engine. So you can say recommendation is actually, all those recommendation systems are actually the part of NLP only. NLP stands for what?
Natural language processing.
Natural language processing. So whenever you say NLP, natural language processing, so this one, recommendation engines. If you want me to develop recommendation engine in Python, I will show you. Suppose if you type a name of some movie, suppose you type the name of the movie like this, right? So you search for this movie. I will develop a system which will give you 10 more movies which are related to this one,
Similar to that.
which will
Netflix,
be
of
recommended,
course.
right? Netflix, that's the best example. So what Netflix actually makes use of? It makes use of recommendation engine only. And for recommendation engine, what you need? You need this kind of algorithms.
Yes, sir.
And how we implement this kind of algorithms with code generation.
Generation.
So whether it's a recommendation engine or sentimental analysis.
Sentimental
is
analysis,
also
right,
an
sir. I have
example
done.
we can give for NLP.
Mm.
For example, I want to know what people are talking about Mr. Narendra Modi, whether they are positive, negative, or neutral. I can make use of NLP in that case. Right? So it's really interesting actually, and when we will get a chance, we will implement that. Right? So
Yes,
yes,
sir.
this is about EDD process model. Another thing which I wanted to discuss, maybe we will discuss it in next class. This CRISP DM. So this CRISP actually stands for Cross Industry Standard Process for data mining. Cross Industry Standard Process for data mining. We will see what it is actually. Maybe in next class we will talk about that one and we will try to complete that. Okay. So any doubt, anyone?
No, sir. Sir, did you send the drive link?
Oh no, I will do it today. I will do it today. I will just share it in the group. I will just upload all those things on the drive and share it in the group.
Yes.
Yeah. And just anyone absent, let me see. Okay, all of you just send your seat numbers in the chat box. There are total 10 people, right?
Yes, sir.
I am able to see only 8. Just send your seat numbers, all of you, and then I will stop. 1, 2, 3. I got 4. 6. Disha, do you have your seat number?
So what?
Disha, do you have your seat number? Did you send it? Because I think
Yes, I
you.
sent 658.
Okay, no problem. I think everyone has sent it, no problem.
So also
Yeah,
the things that you were mentioning, DDL, DML, DCL, TCL, and
right,
DQL,
right.
we haven't been taught that in a structured way. So if
So
we
you tell
wanna,
me, do you people want me to discuss those things? Because it will not take that much of time for me to discuss these things. Maybe 1 or 2 class, and I will discuss it. Because see, once you are clear about these terms, right?
Mhm.
Discussing these theory things is not that much difficult. Let me be.
Yes,
Let
sir,
me
we
make
should
that.
just discuss it once because everybody is not on the same terms.
Yeah, people are doing like different. We all are doing different courses outside, like outside the structure. So this hasn't been taught to us in a structured way. So it would be good if you
So see,
brief over it.
if I want to tell you frankly, discussing all these theoretical concepts is not that much difficult. All this is theory. All this
Mhm.
theory actually. Most of them I know that you people will also be able to do that because you teachers that you need to read and you need to understand, right? But learning these things with some practical approach always helps. So maybe no problem. What I will do, I will try to talk about those things. What is digital DML and how it can be used, right? But you people have actually used databases, right? At least
Yes,
MySQL is
we
one.
have used it.
So do you have MySQL installed in your case?
So we haven't
Yes,
used
sir.
that grant and revoke DCL and
Yeah, some of these we
transaction
haven't even
control
used.
and
Drop,
we have
truncate.
just used that basic level. Like we have to create table, how to fetch
Okay.
the data, how to use select and insert, update, delete, merge.
Okay. On
Right?
which operating system you have learned that?
Windows.
Windows
Windows.
operating system. Okay.
Yes, sir.
No problem. If you want, I will give you an idea about all those things. Okay. And if possible, do you have any database installed on your machine? Any of the databases installed on your machine? MySQL
No,
or
sir.
Oracle kind of thing? No, right?
No, sir.
Do you know how to install?
No, sir. We have to refer a video for that.
There is only 1 or 2 commands you are going to require. And I can see all these things actually are there on my YouTube channel also. That's why if you people really want to understand Python or maybe from basics, you can always refer this, right?
So
Yes, sir.
you could also
Definitely.
do this, that if we want to focus on more practical stuff, we could do this theory stuff. We could refer some videos, your videos, or any other videos that you could send.
For what you're saying? For
Like if we, instead of like there's a lot of theory and we are like whatever we don't know, we could refer videos and all that. So if you could send the links, we could do it on our own as well.
for theory you are saying?
Yes, sir. For
Then
theory.
what will be doing in this?
नो सर, नो थ्योरी सर, लेक्चर में आप सिखाइए, और जो प्रैक्टिकल इम्प्लीमेंटेशन such as coding and all, so for that you can give your YouTube.
Okay, videos you are saying. Okay, that can also be done, no problem. So
For
what I will do is,
implementing for a practically if we implement in our laptops.
sure. So what I will be doing is I will be showing you some sample examples, right? I will send you the videos for that, and you refer it, and you can do whatever. If suppose you require MySQL database for that, right? So what I will do, I will show you how to install it first. I will show it to you practically, and you can do it, no problem. Right? So there is actually one command only you require for installing MySQL database, and if you are talking about grant and revoke, again, grant and revoke is just, if I show you one command, you will be able to understand. Grant is like what? Give the permission, and revoke is take the permission. But anyway, no problem. I will discuss that. Yeah, I will execute some statements in front of you in the next class. No problem. Okay?
Yes, sir.
Okay. Then that's it from my side. We will meet in the next class. And I will share all those documents, whatever I have told you. I will share the link in the group.
Yes.
Okay. Bye.
Okay, sir. Bye, sir. Thank you.
Yeah.